Hi everyone. Now in this video, I'm going to explain about another new topic which is called Integrated Rate Law. Okay, now before we continue, before we go further, as you can see in the topic itself, it has Integrated Rate Law. So Integrated Rate Law is actually a formula that we get from integrating the rate law that we draw. Now let's make a short revision. Now, consider we have A producing product. How are we going to write the rate law? So for this, rate equals to K A 0 or just K. For first order, we are going to write rate equivalence to K A 1. But like I always say in mathematics, we don't use 1, so we just put it like this. And for second order, rate equals to K concentration A by the power of 2. Now, from the three rate law given here, when we integrate it, we are going to get this formula. So this is the formula, integrated rate law for zero order. Okay, and then this is for first order, and this is for second order. Now, lucky you no need to know how to integrate this rate law to get this. Okay, so actually it comes from this, you integrate it and it will become this. So what is this A naught? Okay, given here A naught is the initial concentration of A. At is the concentration of A at T or certain time. So K as usual, it is a rate constant. And T is referring to the time of reaction. So what can we get from this integrated rate law? We can actually get the concentration at certain time. That is the difference between differential rate equation and rate law. For integrated rate law, we can get the concentration after certain time, after the process and at certain time. So you have to memorize these three formula. So let's take a look at the example. How are we going to use the integrated rate equation? The following equation shows the decomposition of SO2Cl2. With a rate constant, as you can see, you are given K equivalence to, we have K equivalence to 5.09 exponent negative 4, S negative 1. And you are given as well the equation. Now at 320 K, 1 mole of SO2Cl2 is left to decompose in a 2-liter container. Determine the concentration of it after 30 minutes. So how are we going to solve this question? You might wonder, what is the order for this reaction? It doesn't even mention anything here. So do not panic when you don't have the information about what order it is. Please take a look at the constant. Okay, please take a look at the constant. Now look at the unit of the constant. The unit here is S negative 1. In previous video, I already mentioned what is S negative 1. So whenever you see the unit of the constant S negative 1, this is referring to first order. Okay, So this is actually a first order reaction. And the question is, 1 mole of SO2Cl2 is left to decompose in 2 liter. This determines the concentration of SO2Cl2 after 30 minutes. So, the concentration of SO2Cl2 is 1 mole over 2 liter. So you get 0.5 molar. So this is the initial concentration. So since this is what we call first order, so let's take a look back. Okay, this is the formula for first order. Ln O ini T KT. Sorry. Equivalence to KT. Is it? Yeah. Oops. Okay, so we have this here. So we already have the 0.5. Substitute all the value that you get. So ln 0.5 over SO2Cl2 at time given, which is 30 minutes. Your K given 5.09 exponent negative 4 second. So when this is second, so your 30 minutes you have to convert the 30 minutes to second as well. Okay, so we have 100 at 0. So calculate. What are you going to get? Now, according to my calculation, you are going to get you are going to get 0.20 molar. Okay. Okay, so let me elaborate. Maybe some of you don't understand how to do the mathematics. Let me try to give a idea first. Maybe you can. Okay, so we have given to you ln 0.5 over SO2Cl2 equals to 5.09 exponent negative 4 and 100 at 0. We have to change it to second because the constant is in second. So what you can do, at this side, we anti-ln it. Okay, you can anti-ln. So when you anti-ln, you're going to get 0.5 SO2Cl2. And on this side also, we have to anti-ln it. So we are going to get 2.4998, and therefore this one 0.20. Okay, so this we have anti-ln. So all this also anti-ln. Okay, so there you go. We're going to get this. Okay. All right, there you go. Okay, so how about if you give a try to do number 2, number 3, number 4, 5, and 6. Should you have any question, please message me. Thank you.